just go up and down. Let me do the fundamental frequency. I know what goes circular, right? So ahead of time.
The Doppler effect. In Sheldon's words,
it's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
The Doppler effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wavefronts bunch up, and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a high frequency, and if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect, the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes sense, but it gets interesting when you consider some of its applications.
Bomb. That's because the other three are all manifestations of a phenomena called resonance. The concept of resonance is one of the more spectacular effects in physics. It's the tendency of a system to vibrate or oscillate dramatically when it's driven at certain frequencies. We've all experienced this effect. It can be as enjoyable as being pushed on a swing, or as jarring as driving on the rumble strips on the side of a highway.
Yeah, keep it up. Woo! That's sick, alright.
Key features of waves. First off, wavelength. A wavelength is the length of a full cycle of a wave, from one point to the next same point. It's easiest to think of as the distance from crest to crest or from trough to trough. And we measure it in meters, and it's given the symbol lambda, a nice Greek symbol. The amplitude is like the size of a wave, but we need to remember that it's measured from the equilibrium position, or the central line, to the crest, not from the crest to the trough. Finally, frequency, which is the number of complete waves to pass a point every second, and it's given the unit of hertz. So an example of this would be if 10 waves pass in 2 seconds, the frequency would be 5 hertz. Using these things, we can actually now calculate the speed of a wave using the equation speed equals frequency times wavelength, or to give it in symbol form, V equals F lambda. So there's a lot to learn here, but once you've learnt these core concepts, it will give you much more confidence in the rest of the topic.
So do you hear that? The wobbling? So when it's loudest, this wave is tallest, and when it's softest, the wave is shortest. And that's because you're getting alternate periods of constructive and destructive.
When you're real close to the speaker, the waves might be really intense like this, right here. However, when you're really far away, even though they're the same types of waves with the same frequency, the same wavelength, it's essentially the same sound. It's just not as intense or not as much energy in those sound waves as before.
instrumental, which is in this case low C. And in fact, they sound more and more faintly as they go higher. Any note I strike will contain its own series of overtones. But the lower the note I strike, the more abundantly audible will be its harmonic series, which accounts in part for the comparative richness of this low C. Now remember, I spoke of a preordained order in which the overtones appear. Let's see if I can make you actually hear those overtones in that order.
Node. Any part of a standing wave that remains stationary. The string of the guitar moves back and forth past the nodes when it is being strummed. The node is the midpoint of the string. Destructive inference. Waves that overlap each other and decrease in amplitude. The drops of rain create a rippling effect in the puddle that makes the water waves overlap each other, therefore decreasing the amplitude of the waves. Rarefaction, a lower pressured wave.
Large wings and soft plumage.
May you please repeat the word?
Heron.
May you please use it in a sentence?
If Gail had not seen the
Decibel levels, a measurement of sound levels. A baby's cry can measure up to 122 decibels. Normal voice levels, on the other hand, only averages up between 45 to 70 decibels.
The moon right now. The moon is blocking the sun.
Medium, an intervening substance through which something else is transmitted or carried on. A medium can also be defined as something with the mass and matter. Mechanical waves are transmitted through mediums such as sound and water. Electromagnetic waves don't need the help of mass and matter, therefore they require no mediums to transmit waves. Examples are light, X-rays, and microwaves. Thank you for staying to the end of this boring video.